So this is the final video under this lecture series, solving simultaneous equations using matrices. Right. Now, given two simultaneous equations, we can write this in matrix form, right? So, as a matrix equation, how we are going to do it? Now, you can see these are coefficients A, B, P, Q, right? So, you can write it like this: A, B, then P and Q. Right. Then write X and Y like this. X first, Y next. Okay. So even if Y terms are given first, you have to change the position and write it like this. Right. First X terms come. So then you will not make anything wrong there. Then C, D. Now this is a matrix equation. Matrix equation where let's call this matrix A, B, P and Q, and let's call this matrix. These are the variables you have to solve for. So I'm going to use capital X, Y. Then let's call this matrix B. In that case, this equation can be written as AX equal B. Now, you need to find values for X, right? Then you can find X. How do you do it? Now, here's the thing. So, please learn this technique. Now, you have to solve for X, which means X should be isolated. X matrix should be isolated. So what about A? A should be taken off the equation from the left hand side, right? So how do you get rid of a matrix from one side? You have to multiply the equation by inverse of that matrix. Now make sure the order of multiplication. Now if A is on this side, if A is pre-multiple of X, then you multiply the equation by A inverse on the left hand, on the left, right, from the left. So you could write this: A inverse A X equal, then you write A inverse here as pre-multiple of B. See, that's it. Then A inverse into A, we learned that we have this property for inverse functions, that is, when inverse a matrix, when you multiply a matrix by its inverse, that is equal to identity matrix. So here we have I times X equal A inverse B. I times X equal A inverse B. Now I means the identity matrix, it's like 1 in numbers universe. So when you multiply any number by 1, you get the same number. So I times X is just X inverse B, provided determinant A is non-zero, right? So you have to make sure determinant A is non-zero. If determinant A is 0, then you can't find solutions. So solutions does not exist. So there are three types. I mean, in one possibility being there can be solutions to these simultaneous equation. The other possibility is there cannot be any solutions. The third possibility is there are infinite solutions. That is a third possibility. Right? So we will talk about them in the class. Right. So now you can see here that this is why you learned about inverse. So if you know inverse of A, then you multiply that by B and you get the values for X. That's it. So let's do some examples now. Right. So let's look at this example. You can solve these equations simultaneously. That's okay. But we will see how to use matrices on this. Now 3x plus 2y equals 3. 2x minus y plus 4. This is actually you can write it as plus minus 1 times 1 equals 4. So the coefficient is minus 1 here. So if you can get that right away, then you don't have to write it like this. So it is minus 1. So extract the coefficient matrix from this. Let's say let A be 3, 2, then 2 and here minus 1. First thing you do is to check whether the determinant exists. So determinant is non-zero. So det A in this case is 3 into minus 1 is minus 3, then minus 2 into 2 is 4. Yes, this is non-zero. Then you can find inverse matrix from this. So you don't really have to find inverse matrix. You can just solve for x. Right? Let's say x in this case. So like this, x y matrix equal. Now let's write the inverse of A first. So first 1 over minus 7. So what is inverse? Swap these two, minus 1, 3, then put negative signs, negative 2, negative 2. Right. Just change the sign, change the signs. Then 3, 4 is matrix. Now we have a multiplication. That's fine. X, y, minus 1 over 7. What do you get? Minus 3, minus 1 into plus 3 is minus 3, then minus 8, minus 11. That's it. Next, second row with the first column. So minus 2 into 3 is minus 6, 3 into 4 is plus 12, plus 12 minus 6 is plus 6. Right, that's it. So what are the solutions? So you can write it like, when you put 7 minus 1 over 7 inside, then this becomes 11 over 7, and here this becomes minus 6 over 7. Can get the answers right away. So what is x? Now these are two equal matrices. If matrices are equal, then the corresponding elements are the same. Therefore x is 11 over 7 and y is minus 6 over 7. Right. So notice here you don't have to deal with many letters, just deal with numbers only when it comes to this. Now you might not see the difference between this technique and the usual technique used to determine the solutions to simultaneous equation, but when it comes to system of equations where you have n number of equations and n number of variables, then this comes in very handy, right? So that's why we learn about matrices. So you will do them when you go to universities. Right. Now let's look at some examples. Right. So let's look at another example here. So you have to extract the coefficient matrix. Let the coefficient matrix be minus 5, from here plus 2, from here plus 10, from here minus 5. First check the determinant. Right? Minus 5 into minus 5 is 25. Then put minus 10 into 2 is 20. So the answer is 5. So determinant is 5. That's fine. Right. Therefore, now you can write down the equation. So equation is x equal a minus b, something like this. So B matrix is this, X matrix is X over Y. So you don't have to write this all the time. So instead you can just write X, Y matrix is equal to, now write down the inverse of this matrix. So inverse of a matrix, you learn how to find inverse. 1 over determinant, that is 5. Swap these two numbers, minus 5, minus 5. Then multiply the rest by a negative sign. So minus 2, you multiply by multiply 10 by minus sign, so minus 10. Minus 5. Then 3, 10. Right. So let's multiply and you get 2 by 1 matrix when you multiply these two, because you get only two numbers. So minus 5 into 3 is minus 15, plus minus 2 into 10 is minus 20. So this is minus 35. 15 and 20 both are negative, so that is negative 35. Then negative 30, negative 50, so negative 80. This is a scalar, so you have to multiply each element by this scalar. So what do you get? So when you multiply by 1 over 5, that's actually dividing by 5. So when you divide minus 35 by 5, you get minus 7. Then when you divide this by 5, you get minus 1, 6, minus 60. Right, x over. See how easy this is? Therefore, x is equal to minus 7 and y is equal to minus 60. Right, so this is how you solve simultaneous equations. So we'll do more examples on this till the class. Right. So thank you. One last thing, right? Before we move on, I want you to put a final note on this. So inverse, properties of inverse, and what we can do with the inverse. So so this will be helpful when you practice past paper question. So do not go anywhere. Right. So provided A and B are invertible, so you can use these properties in the exam. Inverse of a product. So you have a product, then you have to take the inverse. So the inverse of a product is equal to product of the two inverse, but the order has changed. So you can see that AB inverse is equal to B inverse into A inverse, just like with transpose. So AB transpose is equal to B transpose into A transpose. So the same thing here. And transpose of A inverse is equal to inverse of A transpose. Right? So this also hold. So please keep that in mind. So when you take the inverse of a product, then the order change. When you take the inverse transpose of an inverse, that is also equal to inverse of a transpose. Right. So the exam, this has come up a lot, right? So solving equations. Now suppose we'll start off with simple one. Q times P, these are all matrices, right? So suppose they all have, they are all invertible. QP equals R. Then you are asked to solve for P. Oh, subject P, isolate P. P tani karanda anit eva ginniya. Etakota mokada karanne? What do you do? So P has, this is the enemy. This is the enemy we have. To get rid of this enemy, you have to multiply the equation by inverse. So the first thing you do, you QP, you write it like this, and R. So you have to multiply Q from this side by Q inverse. So you do the same. So these two would be I times P, Q inverse R. I times P is just P equal Q inverse R. Very simple. Right. Now let's see, how do you solve for Q instead? How to solve for Q? So what do you do? QP, right? QP equals R. Now we have to solve for Q, so you have to get rid of P. To get rid of P, then you have to multiply this equation by P inverse. Where do you multiply? So you multiply from the right. You write P inverse, then here on the right you write P inverse to the right of R. So P inverse becomes I, then R P inverse. Q times I is just Q. Very simple. It's very simple. Let's look at another one. So let's solve for P in this case. Now notice here, P is in the middle, right? P is in the middle. So this is what I'm going to do. Q, P, B, right? So R, A. Now to get rid of Q, you have to multiply by Q inverse from the left. So Q inverse. Then this will become I. Now we have to get rid of B as well. So we have to multiply by B inverse. Okay. First let's do with this Q inverse from the left. So you multiply by Q inverse. Then to get rid of B, you have to multiply this the whole equation by B inverse from right. Then multiply B inverse. This becomes I. This also becomes I. Here we have Q inverse R A B inverse. I P is P. P I is also P. Therefore, P is equal to. See how easy this is. So, in this case, we assume that both Q and B are invertible. So if they are not invertible, then you can't solve this equation. Okay. So thank you for watching.